Here we have a statically indeterminate beam subjected to a concentrated load. We wish to analyze it using the force method. The beam has a degree of indeterminacy of 2, so we need to pick 2 of the reactions as redundant forces. Let's make the vertical support reactions at B and C redundant. After removing the redundant forces, the beam is going to deform like this. We refer to the vertical displacement at B as delta B and call the vertical displacement at C delta C. Then we can write the compatibility equations this way. To solve for the unknowns, we first need to calculate these displacements. Here is how we calculate delta B. Here is how we calculate delta B. First, we need to write the bending moment equation for the statically determinate beam under the applied load. Here is the equation. Next, we replaced the applied load with the virtual vertical unit load placed at B and write the moment equation for the beam. The virtual load divides the cantilever beam into 2 segments. The bending moment equation for the left segment is x minus L. But the right segment of the beam has a 0 moment. To calculate delta B, we need to integrate m times m star. Here is delta B. We repeat this process for calculating delta C. Here is m. Here is m star. And here is delta C. We have 4 more displacements to calculate. First, let's determine delta BB. This is vertical displacement at B due to a vertical unit load applied at B. Since the unit load and the virtual unit load are applied at the same point and in the same direction, m and m star are going to be the same. Here is the bending moment equation. And here is the equation for delta BB. Delta CC, vertical displacement at C due to a unit load placed at C, can be calculated in the same manner. Here is the moment equation, and here is the displacement. Next, we determine delta BC. This is vertical displacement at B due to a vertical unit load placed at C. In this case, m and m star are not the same since the real load and the virtual load are applied at different locations. Here is m. Here is m star. And here is the integral of m star. Finally, we calculate delta CB, vertical displacement at C due to a vertical unit load at B. What we refer to as m when calculating delta BC becomes m star here, and the m star we used for delta BC becomes m here. Not surprisingly, delta CB equals delta BC. Now we can write our compatibility equations and solve them for the redundant forces. The remaining unknown reaction forces, there are 3 of them, can now be calculated easily using the equilibrium equations.